Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about two ideas. The first one is the rank of a matrix, and the second idea is the nullity of matrix. And we're going to relate these two ideas with the idea of dimension, which I have actually talked about it in the previous video. Okay. So here is the definition of rank. The rank of a matrix A is the dimension of its row and column spaces, and it is denoted by rank of A. So this is the representation that you can use to denote the rank of a matrix A. And this is the important theorem that you might want to consider. So here is if you have any matrix A, then the rank of A transpose, so the matrix is being transposed, the rank of it will be equal to the rank of the original matrix of A. And here is the simple proof where the idea of this proof, I think, can be easily understood if you perhaps try to visualize the matrix itself. So here is, for example, matrix A. So let's say matrix A has 1 to mth row and 1 to nth column. So here is matrix A, and we have A transpose. So here is A transpose, where, for example, if I were to construct this matrix, hang on. Therefore, we can easily consider, for example, the first row here will be the first column. So therefore, you will have 1 to up to nth row. And then, of course, if you think about it, the second column here, sorry, the second row here will be the second column. And, you can think of it as the last row here will be the last column for this A transpose matrix. And here we have 1, 2, up to mth columns. So in order to prove the whole statement given here, we want to prove that the rank of A transpose is equal to the rank of A. So first of all is we start off the discussion with, well, the rank of A transpose. Like I said earlier here, the rank can be found when you consider either the dimension of the row or column spaces. So let's consider the rank of A transpose as the dimension of column spaces in A transpose. So where are the column spaces? Here is the column spaces. Yeah, you're talking about the columns here in A transpose matrix. And notice that when you talk about this column, this is actually the same thing as the row of A matrix. If you talk about this column of A transpose, this is the row of A matrix. So therefore, it makes sense to replace column of A transpose with the row of A. And what is the row of A? So like I said earlier, the dimension or the rank of a matrix can be found by either dimension of row or column spaces. So if you talk about a row of A, the dimension of a row of A, that will give you the rank of A. So there you go, you have simply proof that this statement here is true. Okay. Now here is a simple example. We're going to show that the rank of A is equal to the rank of A transpose, and we're going to start our discussion by finding what's the rank of A. So here the rank of A can be found if you consider, for example, here is matrix A, and you can consider doing elementary row operations and reduce this matrix to REF. And based on this REF, you can then ask yourself or count how many non-zero rows. So rows that have non-zero. So therefore, the rank is just the number of non-zero. So the number of non-zero rows got. Let me just write it properly. Okay, so therefore, rank is just number of non-zero rows. So that is the rank of a matrix, and this idea, well, I have already discussed this idea in the earliest videos, in one of my earliest videos related to linear algebra. Okay, so without further ado, let us try to reduce this matrix to REF, reduced echelon form, row echelon form. Okay, so for here I can see 1 over 3 multiplied with the first row, I will get 1, negative 1 over 3, 5 over 3. So here is 2, 1, 3, 0, negative 5 and 1. Next, I'm going to turn this value into 1. So that would be the second row plus negative 2 of the first row. So here I will have 1, negative 1 over 3, 5 over 3. So for this one, 2 minus 2 is 0. 1 plus 2 over 3, that will be 5 over 3. Here is 3 minus 10 over 3. So, sorry, this is 3 minus 10 over 3. So 3 is actually 9 over 3. So 9 minus 10 over 3 is negative 1 over 3. Okay, so the third row remains as it is. Now next is I'm going to turn this value into 1. So I have to multiply the second row with 3 over 5. Okay, so here I have 1, negative 1 over 3, 5 over 3. Here is 0. 5 over 3 times 3 over 5. The value is 1. So here is 3 can be cancelled out. So negative 1 over 5. So that's the result on the second row. And the third row remains as it is. Well, our next step is to change this to the value of 1. So, 0. So therefore, R3 plus 5, second row. So the result is 1, negative 1 over 3, 5 over 3. Here is 0, 1, negative 1 over 5. And then for this one here, 0, 0, negative 5 plus 5, 0, 1 minus 1 is 0. So this is the simplest form. This is REF, row echelon form. And based on this, the number of non-zero rows is, this one is non-zero, this one is also non-zero. Therefore, the rank of matrix A is equal to 2. Okay. Now we are going to demonstrate that if you transpose this matrix, the rank of the transpose matrix is also equal to 2. Okay, so that is the next thing that we're going to do. Well, I'm just going to erase this part since we are done with everything here. Okay, so we're going to start off with considering what is A transpose. So A transpose is equal to 3, -1, 5, 2, 1, 3, 0, -5, and 1. So this is our A transpose. And again, we are going to consider the elementary row operations, and then we are going to reduce it to a simplest matrix, the row echelon form. And we can start off with, well, I can see here is value 1. So I'm just going to, how do I say this? I'm just going to replace the row, the first row with the second row. So we're going to switch the rows here. So R2 switch with R1, and the result is -1, 1, -5, 3, 2, 0, 5, 3, 1. Okay, so next what I can do is I can turn this into the value of 1. So multiply the first row with -1, and the result is 1, -1, 5, 3, 2, 0, 5, 3, 1. Next, what I can do is I can turn this value to be equal to 0. So I'm going to consider R2 plus -3 R1. So here I will have 1, -1, 5. So 3 minus 3, 0. 2 plus 3 is 5. 0, -15. Also, I need to consider turning this value into 0. So we have R3 plus -5 R1. Therefore, 5 minus 5, 0. 3 plus 5 is equal to 8. 1 minus 25 is -24. Okay. Next, what I can do is I can, well, consider turning this value to be equal to 1. So 1 over 5 multiplied with the second row. So I have 1, -1, 5, 0, 1, -3. So here is 0, 8, -24. Next, what I can do is I'm going to turn this value to be equal to 0. So I should consider this process, R3 plus -8 R2. And the result that I will get is as follows: 0, 1, -3. So 0, 0, 0, 8 minus 8, 0, -24 plus 24 is also 0. So here is the REF matrix, and as you can clearly see that here is the non-zero row, here is also the non-zero row, and therefore the rank of A transpose is equal to 2 as well. Okay, so we have managed to show that through this simple example, we can see that the rank of matrix A is equal to the value of rank of matrix A transpose. Okay, right, now let's move on to the idea of nullity. So nullity of a matrix A, again, the idea here relates with the idea of dimension. So here we have nullity of matrix A is actually the dimension of its null space. So dimension, the idea which you have already seen in the previous video. And nullity of matrix A can be denoted by this expression here. So nullity of matrix A, okay? Now, basically, do you remember what is the null space? Okay, so I'm just going to do a quick recap on what is null space. You have already seen it before in the previous video. So basically, when you have matrix A, you can get the null space of that matrix, and the null space of that matrix can be obtained if you consider this process. We have matrix A multiplied with the unknown variables of x must be equal to vector 0. So this is the process that you have to consider in order to find the null space, and you shall try and get the solutions for x. Now from that particular null space, you should be able to determine what's the dimension of that null space. Therefore, nullity is equal to the dimension of the space, the null space. Okay, so that's the idea of nullity. Okay, so here is a simple example. I'm just going to give two examples related to nullity of matrix A, and then more examples will be given in the next video. Okay, so for this example here, we have matrix A, and based on this matrix, I can write down again. So this is the matrix 1 1 0 1 negative 1 1. So this is A. So you have to consider this system of linear equations in order to find the null space. So clearly this is a 2 by 3 matrix. Therefore, for x here, we are going to have 3 by 1, and that shall tell you the number of unknown variables. That would be x1, x2, x3, and here on this side, since this is 2 by 3 with 3 by 1, so this should be 2 by 1 matrix, and the result here is all going to be 0. So this is consider the system of linear equations. Okay, A times x bar is equal to this 0 matrix. Okay, right, so in order to solve this equation, we can go to augmented matrix straight away. So the augmented matrix will look like this: 1 0 negative 1 1 1 1 0 0, and we can start off with turning this value into 0. So here we'll have the second row plus negative 1 of the first row, and you shall get the following result. So 1 minus 1 is 0, 1 0 is 1, 1 plus 1 is 2, and here is 0. And this is already simplified, a simplified version. So therefore, what we need to consider next is we are going to consider this row here, and that tells us that here we have x2 plus 2x3 is equal to 0, and therefore x2 is negative 2x3. So this is the first equation that you have. And next is this one, which is x1 minus x3 is equal to 0. Therefore x1 is equal to x3. This is the second equation. So notice that we have two equations and three unknowns. Therefore, one of it is going to be a free variable, and we're going to let x3 equals to any alphabet that you like, maybe equals to t, where t is any real number, can take any real number, and therefore, and so the value of x2 is just equal to negative 2t. So x3 is t, so negative 2t, and the value of x1 is equal to t. Okay, next we can represent the result as such. So here we have so I'm just going to write down some notes here, represent the results as So here we have x1, x2, x3, and the results are t, -2t, and t. And we can represent it in such a way that we only have numbers in the matrix, and we can take out t outside. So here we have t, 1, -2, and 1. Okay, so you can see clearly that t times 1 you get t, t times -2 you get -2t, t times 1 you get t. Therefore, the null space is equal to 1, -2, and 1, and dimension of null space is equal to nullity of matrix A. So this matrix, nullity of this matrix, so I can just, so this matrix is A, so we just say nullity of matrix A, which is equal to 1. So the dimension of null space is actually, this vector here. We only have 1, so this is the value of nullity of matrix A, and that's the answer. Okay, right, another example before we end this video. So here we have matrix A, and again the question is asking you to find the nullity of the given matrix, and the starting point that we have to consider is x 0. Okay, so this is the starting point, and here is the matrix. So I'm just going to write down the matrix: 1, -1, 2, -3, -2, 1, 0, 4, and here is clearly a 2 by 4 matrix. Therefore, here must be 4 by 1 matrix. So since it is a 4 by 1 matrix, we know that we're going to have 4 unknown variables, so x1, x2, x3, x4. And the result here is going to be 2 by 1, which is 0 and 0. So here is 2 by 1 matrix. So that is our starting point, and we can convert the whole thing here into an augmented matrix. So the augmented matrix will look like this. So we have 1, -1, 2, -3, -2, 1, 0, 4, 0, 0. Okay, so what I'm going to do first is I'm going to turn this into the value of 0, R2 plus 2, R1, and the results are given as such. Okay, -2 plus 2, 0, 1 minus 2, -1, 0 plus 4, 4, 4 minus 6, -2, 0. Okay, next is I can turn this value into 1. So the process is just -1 times the second row, and the result is 1, -1, 2, -3, 0. Here is 0, 1, -4, 2, 0. Okay, next what I can do is, based on this, if I want to stop, I can, but you know, if I want to reduce this part, I can do that as well. So for example, if you want to make it even more simple, you can actually consider taking this value equals to 0. So we have 1 here, and above 1 is the value of 0. So here is the leading 1, okay? And if you want to do that, that means you have to consider the first row plus the second row. So here we have 1 plus 0 is 1, -1 plus 1, 0, 2 minus 4, -2, -3 plus 2, -1, 0, and at the bottom we have 0, 1, -4, 2, 0. So I hope you can see that the number is slightly reduced, and by taking this value into 0, we can simplify the equations that we shall consider after this. Okay, well, so based on this here, we have x2, -4, x3, x4. Okay, so here we have, oops, sorry, I don't have a space. I'm just going to consider this space here. This. So based on this, we have x2 minus 4 x3 plus x4 is equal to 0. So x2 is just 4x3 minus x4. So this is the first equation. Next is I can consider this part. So here I have x1 minus 2x3 minus x4 is equal to 0. So x1 is just 2x3 plus x4. Clearly, what we have is two equations, but we have 4 unknowns. Therefore, 2 of them will be the free variables. And based on this first equation here, we can see that we should let x3, okay, equals to s, and x4 equals to t. So you can just put any name, any variable, any alphabets that you like. So in this case, I'm just putting it equal to s and t, where s and t can be any real number. Therefore, the value of x2 is going to be 4s minus t. Okay, so just substitute s and t accordingly. So 4s minus t, and x1 is going to be 2s plus t. Okay, right, I'm just going to erase this part. So then we can represent the result in a slightly different notation. So we're going to represent the result as such. So here we have x1, x2, x3, and x4, and those are equal to, well, x1 is 2s plus t, x2 is 4s minus t, x3 is s, x4 is t. And we can see clearly that there are s components and t components which can be separated accordingly. So here we can consider just s, 2s, 4s for this one. This one here we have s. This one here got no s, so s is 0 plus. So this part here just concentrated on t. For the first one we have got t. Second here is negative t. No t, so t is 0. Got t, so that's it. Next, we can take out the alphabet so that we only have numbers in the bracket here. So we have s outside. Here we have 2, 4, 1, 0. And t can be taken out as well. So inside we have 1, negative 1, 0, 1. So based on the results here, we can say that the null space of A is going to be 2 vectors here. Okay, so we're going to combine them together. So we use a bracket, 2, 4, 1, 0. 1, negative 1, 0, 1. So this is the null space of A, and the dimension of null space is, or will give you the nullity of matrix A, and the dimension is based on how many vectors are there inside here. So we have 2 vectors, so dimension here is equals to 2. So this is the nullity of matrix A. I think that's all for now. Thank you very much for watching, and I'll see you in the next video with more examples related to nullity and the rank of a matrix. Okay, go.